Right folks, what we're going to be doing today guys is just a little bit of recap what we were doing kind of before Christmas. Starting off just on the circle, we're just going to do it for today and on Tuesdays, or was it whenever we have Wednesday, or is it Tuesday's class as well. And what we're going to be doing, as I said, is just a little bit of recap on circles and some of the principles that we learned, okay? New topic then, we're starting on Thursday's double, okay? So starting off guys, what I'd like you to do is we're going to first of all practice how do we find the centre of a circle when we're usually not given the centre, okay? So on your compass, can I get you to set the radius to 35 millimeters? And anywhere on a page, it doesn't matter if you have an A4 page, an A3 page, if you just have a copy, you can do this. All you need is your compass, maybe a ruler and a pencil. So set the radius to 35, draw on a circle, there we go. Now I know, we obviously know where the centre is, we've just drawn that circle, but in an exam you might have to be told, or you might be told that you have to prove it, okay? So we can see the circle is here, we can kind of see where the centre is there, and I have to prove that though. So what we did in class was we set up two chords, okay? So I'll do a chord here, and I'm going to do a chord here. I won't do one kind of parallel with it, I'll do one at an opposite angle to it, maybe almost perpendicular to it. So two chords, and what we do with those two chords is we are going to bisect them, okay? And where the two bisected chords cut through, that should give us the centre. So neat and tidy. Just go back over that one. And the same over here. Okay. And now just looking at that, connect them up. Yeah. And what we have found now is the centre of our circle, okay? So anytime you find the centre of a circle, and what you're going to do is you're going to get two chords, construct two chords to cut through the circumference of the circles, okay? Of the circle there and there, bisect those chords, and where the two bisectors cut through each other, that will give you the centre, okay? Next one now guys, what I'd like us to do is, very quickly we're going to practice tangency, okay? So once again, make a circle, any length, okay, or sorry, any radius, apologies. This time identify the circle's centre, so my centre is there, and sorry there, let's move that up a little bit, okay, and I'm going to pick a point out here, randomly out there, point P, okay, and we've done this loads of time in class, and what we're going to do is we're going to create a tangent to touch that circle, okay. So first step, you are going to join the centre of the circle to the point P outside the curve. What we're going to do with that line that we connected is we are going to bisect it. Where that line is bisected, right in the middle, I am now going to scribe in an arc or a semicircle from the centre to P is my radius, or from the centre of my line to the centre of the circle. Okay, do a semicircle, and where that semicircle arc cuts through my original circle, that there gives me a tangent from point P. That is my tangent. If I was to connect that point to the centre of the circle, that is my normal. That line there is a tangent. This line here is my normal. Okay, and the relationship a tangent and a normal have to each other is that they are perpendicular 90 degrees. Okay, I could do the exact same at the opposite side as well. So from the centre, and rather than doing the full semicircle this time, I'll just do a little cut like that. That also gives me a tangent at the opposite side as well. I'll just put it in a different colour this time. Here's green. Okay, there is another tangent. Okay, and same thing is we have a normal here too. Okay, excuse me. So there we go. We have a circle point outside the curve, and what we did was join the point to the centre, bisected that line to get the centre of that line from the point to the centre of the circle, and then using the centre of the line swung a semicircle with the radius from the centre of the line out to P, or the centre of the line into the centre of the circle, and where that semicircle cuts through the circumference of my original circle, that's a point on my tangent, okay, where it cuts through. Okay, so if you can get the two of them questions done there now, and you can pause the video before you move on to the next part. Okay. Right folks, the next part we're going to be going on to is another tangent, only this time we have to get an external tangent that is touching both circles. So essentially we want a line that is touching both circles like that, or technically you could have it like that as well. But essentially we want a line that's touching both circles, something roughly like that. Okay? And that's going to be our end result. But what we have to do is we have to prove it, okay? So we did this before Christmas as well. So the first step is we connect both the centres, okay, of the two circles, circle A and circle B. Circle A has a radius of 35, circle B has a radius of 20. Now, in this case, when we're getting an external tangent to touch both circles, okay, what we're doing is when it's external, we are going to subtract here in this case when we want a tangent to touch both circles. So 35 take 20 leaves us 15, okay? 35 take 20 leaves us 15, okay? So what we're going to do is set 15 on my compass, okay, set 15. It's quite an awkward one to do a circle with. And in the bigger circle, what I'm going to do is I'm going to put in that radius 15 circle as best I can. Okay, so that circle there now is, I'm just going to write it on the outside, put it in green, radius 15. Okay, now at this point here, what I'm actually going to do is I am going to do, anytime we actually did a tangent in the previous question, we connected the two centres, or the centre to the point, and we bisected this line. So once again, I have to bisect the line. Okay, so bisect that line, pick a distance bigger than halfway, above and below. I have to extend on that one just a little bit. Okay, get the middle. Now I've got the middle of that line, and what I'm going to do now is I'm going to use from the middle of the line to the centre of either circle, do a semicircle. Nice light semicircle. You can see the idea there. Okay. Whereas really all I actually needed was this part here. Okay, so what I'm actually going to do now is I kind of have all the elements there to be able to complete the tangents that I'm going to need out here. Okay, and this is the point here, okay, where we are going to construct our tangent and our normal. So from the centre of circle A, I'm going to connect this where that semicircle that I've just scribed with an arc, okay, I'm going to connect that to where that arc cut through my small radius 15 circle, and I'm going to extend it on. Okay, and that there technically at this point here is a point, is my tangential point for the tangent that I want that's cutting circle A. Okay, so that would be, I'll just label that, let's call it X. Okay, and the one we're over here, let's call it Y. Okay, but what we have to do is we have to get that tangent. Okay, and there's a couple of ways you could actually do it here. You could do a bit of sliding set squares, and what we've actually found there is a normal of the tangent. So you could create another normal on this circle here, circle B, that is parallel to it. Okay, by literally going like this. So there's a normal, and there will be my other normal at the opposite side. Okay, and technically what I've found there now is Y. Very, very simple, and I can construct my tangent. There's my tangent that is touching both circles externally. Okay, another way I could have done it was, just to show you there, I could have from here to the small circle radius 15, I could have constructed my tangent, just to show you there now. Put that in lightly, but what we'll notice is that tangent, even though it's not touching both circles externally, because I'm not doing it off the internal circle, but the tangent on the outside, the xy tangent that we know is in the correct position, should be parallel to it, and we can see there that it is. Okay, so another way I could have done it, instead of actually doing sliding set squares with the normal, I could have drawn in the tangent off the small circle, gone up to the x, and I could have put in my tangent there. It's just easier to do it with the normal though, because what it does is it gives us both points of contact. Okay, so that is a circle touching externally, okay, or sorry, a tangent touching two circles externally. Now what we're going to go on to is a tangent touching two circles internally. For this one we subtracted, so think of it the opposite way around. We are going to now add. Okay, so two circles down here now once again. I've used the same radiuses, so I'll just put them in there for you so you can see them there, guys. I'm going to be doing it kind of a tangent going internally, so it's going to be a line that's going to go in between, kind of like that. Okay, so something like that there. Alright, and turn that silent. So just a line like that there. Alright, so same radius. I had radius, just so you can see it again, guys, that was a radius of 35. And this one was a radius of 20. Okay, circle A, circle B. So last time it was external and we subtracted, this time it's internal, we're going to add. Okay, so we kind of follow the same steps. So 30 plus 25, this time, as I said, this time we're going to add. This time we have a radius of 55. Okay, so that's the numbers that I need. So first of all, join the two centers. I'm just using green. Join the two centers, okay, and what I'm going to do now is I'm going to get 55 on my compass, so setting 55 on the compass, happy with that, and once again from the big circle, going to swing an arc. I'm not going to actually draw the full circle like I did last time, I'm just going to give you the idea of it. Okay, so that would be a circle there that is radius 55. I'll write that in. Just put it in out here. Radius 55, using the center there. Okay, and like we did last time, we have to, this green line here in the center, we have to bisect that. So, distance over halfway. Try not to get confused. Once again, I'm leaving myself short. There we go. Now, using the center of that, okay, what I'm going to do now is I am going to swing a semicircle. Center of the line to the center of my original circle, circle A or circle B, and swing a semicircle. And what you'll actually notice then, guys, is this point here. Okay, if I connect that back to my big circle, my radius 35 circle, where that cuts through circle A, that is a point, let's say once again we'll call it X, that is a point for my tangent, okay, that is going to touch internally between circle A and circle B. But what I need to find once again is the Y. And if we have the normal, I can go parallel with the normal. So that's my normal there. Bring it across. My accuracy is a little bit out, guys, apologies. There's the idea. Should use green. So there's my Y. So all I've done is did sliding set squares between the two of those. Okay, and then I can connect up my tangent. There's my tangent in between the two of them. Okay, so what we did there now, guys, was we did an external tangent and we did an internal tangent. Okay, and a little bit of sliding set squares and just understanding whether you have to add or subtract. Okay, so do the two of them there now, guys. Okay, and you can pause the video there now before we get on to the last bit. Alright. Right, folks, so what we're doing here now on the last little bit of work we're going to be doing over the next 2 days is when circles are touching each other externally and internally. So the first one we're going to do is we have two circles here, a radius 30 and a radius 20. You're going to have to draw those on a sheet or a paper somewhere, okay, and keep them close enough, not too far apart. You can see the little gap I have in here is roughly about 15, okay. And what we're going to do is we want another circle that has a radius length or an arc length of 17 millimeters to touch both of these. So essentially, when circles are touching each other externally, it's like I have a circle, a center somewhere up here, and they're touching something like that. Okay, so it's going to touch here somewhere and maybe touch here somewhere. But what we have to do is we have to use a little bit of maths simply to figure it out. Okay. So essentially, I have a circle that has an arc length of 70 millimeters that is going to touch here and here. Okay, so it's 70 away from here and 70 away from here. Okay, and essentially all we're using is a little bit of maths. The circle here has a radius of 30. 30 plus 70 is 100. So that's the very, very first one. So radius 70 plus radius 30 equals 100. Radius 100. And in this one, it's a radius of 70 again, sorry, plus the radius of this circle, which has a radius of 20, which equals a radius of 90. So all I'm doing is I'm getting 100 on my compass for the first one. So that distance there. And from this arc, going to swing, or from the center of the first circle, going to swing an arc that has a radius length of 100. Okay. And from this circle, I'm going to swing an arc that has a radius length of 90, because 20 plus the arc we want, which is 70, is 90. So from this circle, there we go. So that's my radius of 90. And where the two arcs cross each other, I have now found the center of my arc that has a radius of 70. And it's very simple now at this stage, depending on my accuracy. I usually you can measure it off your set square again. And I could do 70 there. Or I could just go to the center that I found roughly and try and figure it out just a little bit neater. There we go. And what I've created there now is an arc that has a radius length of 70 millimeters. Radius 70 arc that touches both this circle and this circle, circle A and circle B, okay? So just to prove that then, all I would do is I would join the center of my new circle on my arc 70, radius 70, to the center of this circle here. That shows me there where the point of contact is, and I would do the exact same at the opposite side. That shows me where the point of contact is there. Okay, very, very simple. This is when circles are touching each other externally. Now, not tangents, they are tangential technically, but it's not a tangent straight line. It's a circle arc, okay, an arc of a circle, alright, that are tangential to other circles. And what we do is we add the radiuses when we want it external. Now, the opposite to that is when we want it internal. So I'm just going to go down here, and once again, similar enough setup, okay. We have two circles, radius 30, radius 20, and this time, just work it out in my head, 90 I'm going to go with, okay. So this time I'm going to go with an arc length of radius 90. And this time I want them to touch each other internally. So what that means is I want an arc or a circle here or an arc here that's going to have a radius of 90. That's going to be where the two circles here are going to be inside it, but both touching. Okay, and I'll do it down on this half here. So just rotate it down or move it down there a little bit. So for the last time when it was external, we added the radiuses. This time it's internal, so we're going to subtract. So 90 take 30. 90 take radius 30 equals 60, so that's a radius of 60, and then radius 90 take radius 20 equals 70. Okay, so for this circle I'm going to swing an arc radius length of 60. So once again, get that on my set square, 60. Okay, and just write that in. Arc length is radius 60, and then radius 70 on the other one, and that's from the radius 20 circle, and that's my radius 70 arc. Now I've found the center once again right there, and now I am literally going to draw an arc radius 90, and I'll just join this through, because what you'll actually see, just to show it to you there, is if I was to extend this on, okay, join the center through the center to the opposite side, and I'll do the exact same over here. I'm actually just kind of finding my points of contact at the very start. My point of contact will be up here, and it will be here. But just to prove it, because it's a radius of 90 we wanted, the distance from here to here is 30, here to here is 30, and here to here is 30. So that's 90, okay? And the reason I know that is because the distance from here to that arc, remember, was radius 60. And we know the radius of this circle here is 30, 60, 30 is 90, okay? It's just proving it with maths. Same thing here, 20, 20, okay? And then I guarantee you this bit here is 50, because the distance from here to this arc, the center of the circle here to this arc was radius 70. So that's 50 plus here is 20, 70, okay? And now all I'm going to do is going to draw in that last little arc there, okay? So from there, over there, just very simple like that, okay? And there is my internal tangential arc, okay? That's little bits I want you to get that done there today, guys. That's your work, alright? Just a little bit of recap, and on Thursday's class we're going to be moving on to a new topic, okay?